All right, A3 practice. I'm going to go through the evens here to hopefully give you a little bit of help, and maybe you can use those to figure out the odds. So let's just jump right into it. Number 2, I'm always trying to find the common denominator, least common denominator. So like on number 2, I see that 8t is the least common denominator. So what I'm going to do is I'm just going to multiply everybody by 8t. And I'm going to kind of kill out things on the bottom. So for instance, the 8s are going to cancel, so I'll just have a t times 1. The second one, the t's are going to cancel, so I'll do 8 times 2. And then the third one, all of the 8t and the 8t, all of this cancels out, so I'll just have 17. And when I solve it, I'll get t equals 1. There we go. And then I could always plug it in and see if it works. I'm not going to do this for all the problems, but I'll do it for this one. 1/8 plus 2 over 1, which is just 2, equals 17 over 8 times 1. So is that true? I believe it is true, because on the left I'll have 2 and an 8. And 8 goes into 17 2 times with 1 left over. So it actually checks out. Life is good. All right, scrolling on down, number 4. So on this one, the only number on the bottom is m. So because, technically I have a 1 under the m and a 1 under the 7. So I'm just going to multiply everybody by m. So let's just multiply everybody by m. So m times m is m squared. This one, the m's are going to cancel on the top and the bottom. So I'm going to get 12. And then m times 7 will be 7m. And then I'll have to go ahead and solve this. They're usually going to be quadratics. We can either factor it or we might have to use the formula. But I'm going to set it equal to 0, move the 7m over. So I think it looks like I could do -3, -4. So my solutions would be 3 and 4. And I could plug those two in. Make sure they work, make sure there's nothing in the denominator that makes it undefined. But it looks like we'd be good to go. All right, number 6, over here on the top right. So this one I might have did in class already, but I'll redo it here. So I see that I have an x minus 3, I have a 2, and I have a 2x minus 6. So my least common denominator is going to be 2x minus 6. Now I'm going to strategically write that factored so that things cancel a little bit easier. So let's just kind of put this out, and I'll have 2 times x minus 3 multiplied by all that stuff. There's kind of an understood 1 here, so just think of that as a 1. So you're not really multiplying anything with the bottom. You're only canceling. Well, on the first one, the x minus 3's get killed, so I have 2x. On the next one, my 2's get killed, so I have an x times x minus 3. Sometimes I would have multiplied that out, but I just want to show you what's left over. And then over here, the 2 times x minus 3 cancels out with the 2x minus 6. So I'm just left with that. So I have no fractions after the very first move. Let's work this through. 2x plus x squared minus 3x equals 6x. I probably would have went right to here and just did that distributing by myself in my head to not have to write it again, but no big deal. Let's set it equal to 0. I'm going to have x squared, that'd be minus an x, move the 6x over. It's a minus 7x. And I can't really factor this the normal way, so what I'm going to do is I'm just going to pull out a GCF. And now I can use the zero product property. It looks like either x is 0 or x is 7. So 0 and 7. I just make sure that putting a 0 in doesn't cause me to have any zeros on the bottom or the 7. It looks good, so I think the correct answer here would be 0 and 7. Let's move on down. Let's bust out number 8. So again, if it helps you, think about this 4 as having just a 1 underneath. So I have a 1, an x, and a 2x. So my LCD is 2x. So 2x. So 2x times 4 is 8x. Cancel out your x's. I have 2 times 1. And then cancel out the two x's, I'll have 10. And that'll give me 8x equals 8. Divide, divide. Looks like just one answer here. X equals 1. All right, let's move on down to number 10. So when I have something like this is just a straight up proportion. You could kill them both with 4 times n minus 4. I think it's easier just to cross multiply when you have one fraction equals a fraction. So I'm going to cross multiply 4n minus 12, come the other way, 5n minus 20, and subtract the 4n from both sides, add the 20 to both sides, and it looks like n just equals 8, so no big deal there. Number 12, all right, I got 3 pieces here, so maybe I'll rewrite it just to make it look a little bit more normal. So 4 over x, more better. 6 over 1, 1 over x squared. My eyes just see that a little better. So it looks like the LCD would be x squared. So let's times everybody by an x squared. So I'm going to have the x squared will cancel with one of the x's on the bottom. So I'm going to have 4x on the top. There's nothing to cancel on the next one, so I just have to multiply. And then my x squareds cancel, so I just end up with a 1. So this one I have, set it equal to 0. I have 6x squared plus 4x minus 1 equals 0. I may try to bottoms up here. So let me just try to, I usually try this before I go down the quadratic road, although I might still end up having to. So bottoms up will give me x squared plus 4x minus 6. Can I do two numbers times together to make 6? To do 4. 3 and 2 won't do it. 5 and 1, positive 5. So it looks like x plus 5 and x minus, no, that 5 and 1 won't make 6. What am I talking about? So I only have 6 and 1 and 2 and 3. So it looks like I'm screwed on bottoms up. We're going to have to use quadratic formula. Yup. All right. So quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, let's clean this up a little bit. So that's negative 4 plus or minus. That is 16 plus 24. So that's 40. You know, I'd probably let you get away with that, although it can be simplified down. You know, there's a perfect square of 4 hidden in here. So this could really be negative 4 plus or minus. Square root of 40 is the square root of 4 times the square root of 10, which would be 2 radical 10 all over 12. And then there's a 2 to kill out of all those whole numbers. You know, so this would be negative 2, this would be 1, this would be 6. So I think the best simplified answer would be negative 2 plus or minus the square root of 10 all over 6. Notice I didn't kill I couldn't do the 2 with the 10 because that's protected inside that radical. So you can't really do that. All right, so that was a little tougher. What else do we have? Number 14. So we got a bunch of crap going on here for number 14. It looks like, you know, a squared minus 1 is the difference of squares. You know, this thing right here is really a plus 1, a minus 1. So I'm going to just multiply this whole thing by a plus 1, a minus 1. Let's just start killing people off. So the 2 minus 1s kill off. So I will just have a plus 1 The a plus 1's kill off, so then I'll have 4 times a minus 1. Let's try to do that all together. That's 4a minus 4. And then equals, that whole thing cancels with the whole bottom, so I'll just have 7. Now we clean this up a little bit. 5a minus 3 equals 7. 5a equals 10. Final answer is 2. All right, 16. All right, now we're solving. We're solving these inequality things. So kind of the rule here was you find out when the bottom number is going to be 0, and that's one critical value. So what we have to do here is we have to find critical values. All right, so step 1, set the denominator equal to 0 and solve it. So x plus 1 equals 0. Well, x equals negative 1. This is a critical value, CV. So over here I put my number line, and I don't know, I'm just going to slap a negative 1 on there. And then the second part of this, for your second critical value, is set it up as an equal problem. So 4 over x plus 1 equals 4. All right? So multiply both sides by x plus 1, or cross multiply. And I'm going to get 4x equals 0 divided by 4 divided by 4. So it looks like x equals 0 is my second critical value. And I usually just put the two critical values. Now what that means is, that means that I now have 3 testing regions. I have numbers less than negative 1, numbers between negative 1 and 0, and then numbers bigger than 0. And I basically need to test these points. So I need to pick a number. So maybe I'll pick a number like negative 2. Let's test that and see what happens. So I test it. I get 4 over negative 2 plus 1. Is that less than 4? Well, negative 4 is less than 4. That's true. So yes on this region. Now pick a number between 0 and negative 1. 0 and negative 1. So maybe like negative 1/2. I'll try that. So 4 over, well, a negative 1/2 plus 1 is 4 divided by 1/2. Well, that would be 8. And 8 smaller than 4, that is false. That's a no. And then I pick a number bigger than 0, so maybe I try 1. And 4 over 1 plus 1, is that less than 4? Is 2 less than 4? Yes. So my solution regions are my yeses. So it looks like I have, when x is greater than 0, it works. And then when x is less than negative 1, it works. And since, we kind of have this thing going on, so that's an or problem. X has got to be less than negative 1, or x is bigger than 0. I can't say and, because it can't satisfy both of those at the same time. So big thing is how to get critical values. Denominator equal to 0, and then just set them equal, and then test the regions. All right, so we move down to number 18. Let's try this one. I'll move a little quicker through here. So set the bottom equal to 0. I have my first critical number. Do it straight up as is. Cross multiply. Minus, minus. Divide, divide. Got my second critical number. Now we test. Region, region. Pick numbers in there that are nice. Like 0 is a pretty nice number. Let's test 0. So that would be 10 over 8. Is that greater than 2? 10 over 8, is that bigger than 2? No. Doesn't work, because that's like 1 point something. Let's pick something here in the middle, like, I don't know, negative 4. So I'm going to test negative 4. So 10 over negative 4 plus 8, that'd be 10 over 4. Is that bigger than 2? Yes, that's 2.5. So you're a yes. Let's pick something like negative 10. So 10 over negative 10 plus 8, that'd be like 10 over negative 2. Well, that would be negative 5. Is that greater than 2? That's a no. So no, no, yes. So all of my answers live trapped in between these two. So this is going to be an and problem. So my x's need to be greater than negative 8. And at the same time, my x's need to be smaller than negative 3. Now you can also write it like this. This is called a compound inequality. That says the same thing. X is kind of trapped between 8 and negative 3. All right, let's keep going. Oh, that looks like we're done. All right, those are the odds. Hopefully, or evens. Hopefully that helps you out. See you.